Yeah, hi everyone. So, welcome to another episode of Rocking DFT. So, we have Umesh with us today. So, last time we had a very good session with Umesh where we have introduced the emulation to the audience, right? So today we are just going to take this conversation little bit further. Okay. So what we are going to discuss here in this particular forum, in today's discussion, we will just try to emphasize, right? Like in regards with the DFT, right? So what are the different aspects which we need to look forward when we are using this particular domain called emulation, right? So why I'm just trying to set a context here for the audience, right? It would be easy for them to decipher what we are going to discuss here in this forum today. So as you know, the cost of testing a batch of chips, right, after manufacturing to determine which parts are free of manufacturing defects has reached an alarming threshold of 40% of the cost of building the chip. So it's pretty high, right? Cost of means testing the chip itself is actually 40% of building the chips. So here, the DFT is going to come into the picture. There are the many advantages associated with the DFT and why it is required. For example, the DFT is going to eliminate the risk of passing a problem device that eventually will be called in the field at a cost much higher than if found on the manufacturing floor. And it's going to help us out to avoid the rejection of the faultless devices. And in that particular aspect, it's going to increase the yield. So it's all about how you're going to increase the yield. How many chips you are going to save, okay, which are not having a false, okay. So that's why the DFT is required, and it's going to satiate the requirement, and it's going to reduce the test cost. And the DFT process, if we just think in that particular context, there are many things involved in it. For example, you are using ATPG patterns, you are using an MBIS. In the memory based patterns, you are going to test whether the memories are faulty or not. With the ATPG, you are going to check the scan circuitry circuit. Scan chains, they are going to add the controllability and observability through the serial scan shift register. Okay, so those are the different kind of the pattern set we are looking in the DFT process. Okay, and when you are going to use the scan chain, the problem of the testing of the circuits is going to be simplified. Okay, so ability to automatically generate the test pattern via ADPG tool can alleviate the time consuming and tiresome task of creating the test patterns. Okay, from the design view, the creation and insertion of the DFT architecture is pretty simple. Okay, but as soon means now you know, right, we are working on a very complex nodes, and the technology is becoming complex day by day. We are working on the smaller nodes, and the design and the density of the design is increasing day by day. So the volume of the test pattern is becoming too much enormous. Okay, we are working on the huge and mammoth designs nowadays. So the test pattern volume is pretty much high. So in that particular aspect, when you are going to test these patterns on the tester, so do you feel, is it feasible to test all the DFT aspects of the chip while running the patterns on the tester? I think it's not feasible, right? So here, I think the emulation is going to come into the picture. Okay, so I'll just open the floor for Umesh. So I've just set the context for the DFT, right? Why DFT is required, how it's going to save us, okay, when we are going to test the devices on the manufacturing floor, how we are going to increase the yield, why we need to increase the yield. Okay, so I'm going to open the floor to Umesh. What are his views on the different aspects what we are discussing? Yeah, Umesh. So can you just throw some light, like in terms of the kind of DFT patterns when we are going to test on the tester? Like what kind of issues you think we can face? Yeah. Hmm.
Sure, Kshitij.
Yeah.
Hello, everybody. Hi again.
Hmm.
So, uh, as Kshitij set the context, we are going to talk about uh, uh, running DFT patterns on emulation and the advantage of it. So you know why is DFT required, which Kshitij nicely uh, explained. He articulated it well. Now, why emulation is useful for DFT patterns? The first important aspect is it will accelerate the runtime of the patterns. So many DFT patterns, as Shirish said, they're going to be very big. Like I mean, I'm giving you an example of what patterns we ran. It has some 20,000, 25,000 kind of patterns,
Right.
average pattern. And if you try to run that pattern in simulation, firstly, it's going to take days and weeks. And assume that you run the pattern and say you find a fault at the 28,000 pattern. You cannot go back and run again after correction, because that's going to take another few weeks. Now, here is where emulation is going to be very useful. It is very useful by and in used by various design houses. The kind of acceleration that we get is to the tune of 500 to even 1000 1500 x. So some pattern which can take more than a day can be run in 5 minutes to 7 minutes.
Right.
And if you want to get the waveform dump, nowadays it is you also have the ability to get the right waveform dumps and debug the pattern where it failed. You can also generate the logs. So all that is very useful. So basically, this is the context of why DFT is going to be a big advantage. Uh, or when if it is using emulation to run the patterns, where does
Mhm.
the advantage lie?
Right, right. So yeah, Umesh, you have highlighted a very valid point, right? So emulation is going to help us to accelerate, the testing requirement, what we are looking for, right? So it's going to accelerate the whole process. How soon we are going to, how soon we are going to test the entire stuff, right? It's going to accelerate that particular process. And if you just see pertaining to the DFT perspective, right? We are actually different kind of the pattern set, which are the deliverables from our side, right? As a DFT engineers, we are trying to test many things, and we are having a amalgamation of many patterns which we are going to run on the tester. For example, we have something called the ATPG patterns, which is going to test the scan chain circuitry. Then we have something called the MBIS pattern, which is going to test the memories which are there in our design. Then we have something called the logic best, right? Those pattern set is also there, which is going to test the logic portion of the chip. Okay, so different set of the patterns are there, and those patterns are testing different kind of manufacturing faults. For example, we have the different fault models in DFT. For example, we have the stuck fault model. We have something called the at speed pattern. Okay, that is called the transient fault model. Okay, so in this particular at speed patterns, we have something called the LOC and LOS kind of a classification, which is called the launch of capture, and something is called the launch of shift. And here, when we are trying to generate transient patterns or the TFT patterns, so there we need to worry about the faults in the multi-cycle paths also of the design. So they are the different kind of a pattern set, and since we are generating a different kind of a pattern set, the tester volume is pretty high. Okay. So most of the time, the DFT engineer is going to struggle. Okay. Most of the time, he is going to struggle, like, how I'm going to reduce, the time in which I'm going to test this entire ecosystem. So that is the main thing. Okay, so you have actually touched upon the very valid points, right? Why emulation is required. Okay, what is the need of emulation? How you are going to accelerate this whole process of testing the chinks. Okay, so now in terms of the emulation aspects of this whole thing, when we are going to work on the DFT patterns, when we are going to test the DFT patterns, when we are going to accelerate this entire thing, can you just suggest me, a small, can you just give me a brief overview on the flow perspective, like how it's going to look? For example, I'll just give you a small example for the ATPG patterns, whatever we are generating, whatever the patterns that we are generating, that could be in the different format. For example, there's something called the style, then we have something called the WGL, okay, wiggle format or SVF format. So different kind of formats are there. So whether the emulation platform, what we are going to use, it can understand everything and it can emulate everything, whatever the patterns which we are actually trying it out on the tester later. So can you just throw some light on that particular thing?
Sure.
Yeah.
You made a really good point.
Mm-hmm.
Uh, Kshitij, it's a very good point what you
Mm-hmm.
made. Now I'll take a step back and first
Mm-hmm.
understand how do you prepare your design for
Mm-hmm.
running the DFT patterns. So first thing you have to do is you have to make sure that you have a build on which you can run
Right.
the pattern, the emulation
Right.
build. Now
Right.
for the emulation build, you will need so normally this uh, pattern is run in emulation on the netlist, on the DFT netlists.
Mm-hmm.
Now, if you're
Yes.
running it on DFT netlists, the basic advantage of doing that is firstly, and again, one very important aspect is this is a zero delay netlist.
Mm-hmm.
It
Okay.
is not, SDF based currently is not run on emulator. Zero deal netlist is there.
Mm-hmm.
Just one second.
Okay, so Mesh would be coming back.
Right. Uh, Sorry,
Yeah,
Stitch.
no problem. No problem. Yeah.
Yeah. So basically, the emulation runs on a netlist, and it's a zero delay simulation. HDF currently is not uh, done because HDF will have a lot of issues because it's again involves timing. And first,
Right.
we need to specifically check the functional patterns, the functionality of the
Mm-hmm.
patterns, rather than
Mm-hmm.
getting into the timing part. Because
Mm-hmm.
that will eventually be different.
Mm-hmm. Mm-hmm.
Now, the first important thing is creating that build. Now, the most important thing for creating that build is you should have all the models and the
Right.
netlists, right?
Mm-hmm.
So,
Mm-hmm.
and netlist will be very faster. That's a advantage. And very important thing is now here are certain things that we need to check. If you're getting the netlists now for emulation, we need to change some things like
Mm-hmm.
you might have memories, right?
Mm-hmm.
So you need to get emulation friendly memory models.
Okay. Okay.
You may have analog models. You need to get
Mm-hmm.
the analog models.
Mm-hmm.
You may have IO pads or many of these components which
Right.
we need. We cannot use we cannot use the behavioral models there because they
Right.
have
Right.
to
Right.
run on
Mm-hmm.
the emulator.
Mm-hmm.
So all
Okay.
these models have to be available. You have to make yourself
Mm-hmm.
available all these things. If
Mm-hmm.
once they are available, then the next thing is you can take it through the emulation flow, and you can get a build.
Mm-hmm.
Once you
Mm-hmm.
have the build, now the
Mm-hmm.
next thing that comes is the the pattern
Okay.
generation. Now, normally,
Okay.
uh, I mean, you are the DFT experts, so we
Mm-hmm.
normally get the patterns from you guys,
Mm-hmm.
from the DFT team,
Right.
and we get the patterns and we try to run those patterns. So
Mm-hmm.
normally, in most of the tools, STIL format, still format is
Mm-hmm.
supported. Wiggle
Mm-hmm.
format is also supported. So
Mm-hmm.
all major formats are supported
Okay.
on emulators.
Mm-hmm.
Most of the emulators, actually, at least
Okay.
the ones that I have worked on, yes, they are all
Uh-huh.
supported.
Okay.
So
Okay.
you take that, you run the patterns,
Mm-hmm.
and you can. So there is also something called intermediate step is there.
Mm-hmm.
But again, that is very emulator specific. Sometimes certain patterns that you have, you might want to convert them into a format which the emulator understands. We have that kind
Right.
of a flow as well.
Mm-hmm.
Sometimes you have a flow in which you have a pattern, uh, that pattern is converted into vectors which are pumped through some test bench. There is also that
Okay.
format. So there are
Okay.
various ways that are
Mm-hmm.
done actually.
Okay. 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 Yeah, that's correct. Right now, as you mentioned, right, in your, as you mentioned that, whenever you are starting building the entire stuff for emulation, so you require the different set of the models, right? For the analog, you require an analog models. For memory, you require a memory models. So for ATPG or the DFT perspective also, right, we work on these models. For example, when we have to, generate the ADPG pattern. So we require something called the ADPG models, right? So whether these models are the same or these are the different set
Yes,
of the models.
that's a very good point that you asked.
Mm-hmm.
So basically, for pattern generation, whatever models are used,
Mm-hmm.
we try to use the same models
Okay.
for emulators, because
Okay.
the pattern, there's uniformity in the process. So if
Mm-hmm.
for sometimes what happens is that the ATPG team or the DFT team might use a different model for pattern generation,
Mm-hmm.
and we might use a different model, a
Mm-hmm.
different emulation model
Mm-hmm.
for generating our build.
Right, right,
So
right,
there is
right.
inconsistency, and then
Right.
you might land into debug. So the
Mm-hmm.
best is to take the same model,
Mm-hmm.
because normally DFT models, in my experience,
Mm-hmm.
are synthesizable and they can be ported on Palladium.
Right, right, right. So, generally, when we generate the patterns, we use the ADPG models, for example, generating the ADPG pattern set, right? When we are building the whole infrastructure for ATPG. And when we are running the simulations, okay, so how we are going to verify the patterns? The first phase as a DFT engineer, right? We need to run the simulations, whether it's going to be a zero delay simulations or the timing simulations where we need to provide the SDFs or the delay annotations, timing annotations we have to do. So in these two four phases, before going towards the post-silicon aspects of the DFT flow, in the pre-silicon phase, when we have generated the final set of the patterns, we run the simulations, zero delay and the timing. So while running these simulations, we provide the behavioral model, right? While running the simulations, we provide the behavioral model, which is actually going to test the functionality of those Verilog, modules what we are using in the design. But while generating the patterns, we would be using the ADPG models and other stuff, right? So in the emulation, the main aspect of emulation is that you are emulating the entire infrastructure, what we are going to do later on the AT or the tester where we are actually
Yes,
generating the patterns. Actually, we are running the patterns on the AT. Same thing you are emulating in your emulation platform. But in
yes,
the emulation, you would be eventually generating the test benches in the pattern set also, right?
yes.
Okay. So for these test benches and pattern generation thing, you require the behavioral model, right? Or you would require,
No, no,
okay.
we don't, because the for pattern generation is
Mm-hmm.
entirely done by the DFT team. So whatever
Okay.
you use,
Uh-huh.
we get the same. patterns. So still
Okay.
files and all will be
Mm-hmm.
provided by the
Mm-hmm.
DFT team, and we
Okay.
just take those and run it
Mm-hmm.
over our emulation bit.
Okay, so
So there is
whatever the
consistency
style,
basically.
yeah, whatever the style file we are providing, which is kind of a final deliverable from our side, whether it's related to, ADBG or MBEST or any sort of a style file. So you are actually using that style file and, just trying to, create the emulation infrastructure out of it, right?
Yes,
And then
yes,
you would be doing the compilation and you would be simulating the entire stuff so that when we are going to use this style file later, when the silicon device is available and we are going to run the same style file on the AT or the tester, we would be getting the same results, right?
yes, yes.
Right. That
That's
is
the idea.
the main advantage, what we are going to get it from emulation. That in the pre-silicon phase itself, we are actually
Yes,
foreseeing what we are going to get it on the post-silicon. And by foreseeing those things, we are actually emulating the entire infrastructure in the pre-silicon phase itself. Right?
yes, yes.
Okay, that
Absolutely.
that is pretty good actually, because yeah, it's a kind of a very tedious, cumbersome, and enormous process, right? When we have the whole set of the pattern set and we start, and these patterns start failing when we are going to run on the tester,
Yes,
and at
yes,
the
yes.
time the
And I have few
debugging,
things I want to
yeah,
discuss.
sure, sure,
Yeah,
yeah.
one more aspect is that a very good point that you mentioned is, see, these patterns, whatever
Mm-hmm.
we have, the biggest advantage now that comes with the emulation is you can be ready with all your patterns before the silicon arrives
Mm-hmm.
by testing them faster.
Right, 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 right.
Otherwise, this is going to be a tedious process. That's
Mm-hmm.
a very important thing. But I have one question for you, as you're the DFT expert. What kind of issues in the patterns that you see, which we can test with in by running it on simulation or emulation? So,
Yeah,
what kind of
normal.
maybe constraint issues or what kind of
There could
issues?
be constraint issues. There could be something like, you would be having some problem related to the shifting of the, pattern itself. Okay, hold
Yes, yes,
violations could be a problem. Then, the at speed patterns when we are going to run on the tester. And if you have not considered the false and the multi-cycle paths, okay, and if you have not taken those things into consideration, then your at speed, patterns can start failing on the tester. And this happens a lot when you are having a multi-clock domain circuits, when you have a different
mm-hmm.
clock domains in the design. And very common problem generally we face that the scan chain, which is the basic connectivity chain, okay, that also starts failing. The chain test is the first main or the first basic pattern what we are going to run on the tester, right? If the scan chain itself is going to get start failing, so that is something related to the shift, means you are not able to shift the chains properly, and the shifting is going to if the shifting is the problem, then it could be many issues like hold violations could be a problem. And you need to figure it out, right, to run some diagnostic patterns and other stuff.
Right.
So there are many aspects associated why the patterns are start failing on the tester. Yeah.
Yeah. So basically, even though it is not SDF enabled, there are a lot of
Uh-huh.
issues that can be resolved if you
Right.
deploy this DFT acceleration flow on
Right,
emulator.
right, right,
Correct?
right, right, right. Yes.
No, it
Yeah,
makes sense. It makes
yeah,
a lot of
that
sense actually.
right, right, right. So and apart from the constraint what you have highlighted, that is also a major thing, right? The constraints have not been set properly. So when you are running, even these things you can capture in the simulation, but in simulations also there would be the different timing corners, different
Yeah.
set of the SDFs you would be having. And maybe the design cycle is pretty small and you are not able to validate against all the timing corners in the design, whatever is there for you. So eventually,
Mhm.
definitely, when you are going to run the final set of the patterns on the tester, if you are not able to close on all the timing corners, against your design, so you would start getting the issues there itself, right? So if you have the emulation platform and it can quickly build that kind of an infrastructure, right? in the pre-silicon phase itself, in which you can test the patterns and the acceleration. It's called the DFT acceleration. You are going to test all the patterns at a very fast pace because the simulation process itself is very, very slow, right? So
mm,
emulation is
mm,
going to give you an opportunity to test everything at a very fast pace. I feel that it would be like 5x or 6x, kind of the feature it is providing to the user to test everything, right?
mm.
Compared to the simulation,
Emulation.
normal simulation, what we do.
No, now there are various things like normally the way it is.
Mm-hmm.
Normal scan patterns could be there. They are way
Mm-hmm.
faster, but you could
Right.
also have some patterns which are capture patterns, which have combo plus sequential elements that are tested.
Mm-hmm.
They
Right,
tend
right.
to be little slow,
Okay. Okay.
but the combinatorial logic will be tested
Mm-hmm.
very fast.
Very fast, very
Like
fast. Yeah.
yeah,
Mm-hmm.
like 500 to 600x acceleration is what you can get here.
Mm-hmm.
With this, it takes, like, I will say, as you said, like 10 to 15x kind of
Mm-hmm.
acceleration that you will get,
Right, right,
but
right.
definitely much faster.
Yeah, that's what our DFT engineer is looking for actually, you know. So how we can test the
I know.
things at a very fast pace because the simulation itself is like too much time consumption is going to happen when you are running the simulation,
Yes,
right?
yes.
Okay. Yeah. So I think we have covered the aspects of the emulation, why emulation is required, how it's going to help, what are the common issues we generally face. So you have anything else to add in our today's conversation?
Oh, I think this is a very good start
Right,
to
right, right. Mm-hmm.
work on.
Mm-hmm.
uh, for aspiring engineers, it's a
Mm-hmm.
very good area to start
Right.
working, develop the understanding, and help
Mm-hmm.
resolve a lot of issues actually.
Right, right, right. So, yeah, in the commencing future, we are going to deep dive in the other areas as well, not only the DFT, other problems what we you generally face when you are doing the emulations, and what are the common issues you generally encounter during doing the setup itself, okay, when running the entire flow, right? What are the common issues you're going to encounter? And what kind of strategies and tactics you need to adopt to resolve those issues. So those kind of discussions we need to have in the commencing future, right?
Yeah, yeah.
So
Hey,
what do you think?
one thing I just want
Mhm.
to tell
Mhm.
is,
Mhm.
see, normally the best
Mhm.
option, as you said, is very small subset of simulation patterns. You use
Mhm.
a sanity pattern
Mhm.
to run first, to say that basic stuff is clean, okay,
Right.
on the simulations, the
Mhm.
patterns are okay, and then go to the next level and use the entire pattern set and run it on the emulator.
Right,
That's
right,
the
right.
best way to do it.
Yeah, yeah, yeah.
Since you're talking about strategies, this
Uh,
is one good way of
okay.
uh, accelerating pattern, so that,
Right, right, right.
see, emulator time is also very crucial. It's because you
Mm-hmm.
normally many teams, not just in the
Mm-hmm.
DFT team, where we have verification, validation,
Mm-hmm.
then firmware, everybody using the emulator, so you
So
don't get a lot of
emulation
time.
team is going to, support many other teams, what you are saying, right? It's
Yeah,
not
yeah.
only one team. So it's no, you are
Right.
not actually at the disposal of one team. You are supporting
Correct.
multiple teams at a time. Right.
Correct. So
Right,
that
right.
basic sanity is done simulation level, and then that would be one strategy again
Mm-hmm.
that we have learned over a period of time. That's a
Okay,
good
okay.
strategy to do some
Uh-huh.
basic sanity with simulation, but the
Okay.
real entire pattern you can use
Okay.
the
So in
emulation.
that, yeah, in that case, I can suggest the user, okay, or the viewer, whoever is going to try out the DFT patterns. So, like the chain test is the first main pattern, what we are going to try it out on the tester. So maybe you run the chain pattern first and run a parallel vector. So we have two set of the ATPG patterns. One is called the serial pattern, another is called the parallel pattern. So parallel is something like what you generally run this just to just to avoid the huge runtime while running this pattern on with the simulator. Okay, so that's why you are using a parallel pattern. Okay, but when you are going to run this pattern on the tester, it should be a serial pattern only. Okay, because you would be trying to simulate or stimulate everything from the primary input only. Okay, so uh, in that particular thing, what you have mentioned, the kind of strategy which we need to adopt, so user can run the chain test pattern, one the first pattern, and then he can run the parallel pattern with the simulation, and whatever the pattern which is the final deliverable to the tester, he can run that pattern on the emulator, because that is going to consume too much time.
Yes,
Right,
yes, yes. It's a
right,
good
right, right.
strategy. Yeah.
Yeah, it's a good strategy. Right, right, right. So let's see, like in the commencing future, like what kind of we will just try to deep dive in this particular area, and just try to bring some more important discussions, right? Like how we are going to encounter the issues, what kind of the common issues we are going to get, and how we are going to, resolve those issues. Yeah.
Absolutely.
Okay. Anything else you want to add?
No, Kshitij, I think this is good start.
Okay.
In fact, we have covered a lot of depth today
Right,
in
right, right.
DFT with emulation,
Mm-hmm.
and this is going to be a very good start and
Mm-hmm.
a reference for uh, designers who would be
Right, right.
interested in, you know, doing some work on this part.
Yeah, yeah, yeah. And I will also bring some more technical cognizance on the different set of the DFT patterns which actually we run on the tester, and what kind of the common issues we face while running those patterns on the tester, and how the emulation infrastructure is going to help us out in that particular situation to run those things earlier in the design cycle, not very late in the design cycle.
Yeah,
Okay. All right. Thanks a lot for your time, Umesh. So we will look forward to have another round of conversation very soon.
sure.
All right.
Thank you,
Thank
Kshitij.
you. Thanks
See
a
ya.
lot. Bye